Okay, let's do another example of trig equation, this time a quadratic trig equation. Let's take a look. So it makes this one here a quadratic because of this square here. Okay, this is in the same format as 2a squared minus 1. So first step is to isolate the sign of x, which is the same thing as solving this equation here for a. So how do we do that, right? You can just isolate for a. So you get 2a squared, you get half, and be careful here, a is going to be plus or minus 1 over root 2 when you square root both sides. Meaning, sine of x, okay, sine of x will become plus or minus 1 over root 2. Okay, so we know sine of x equals 1 over root 2. That's a special angle, right? So 1 over root 2 is maybe about there, 1 over root 2. And we know that is pi over 4, okay? So you can see that x will be pi over 4, and it'll make this one here pi minus pi over 4. So pi over 4, and that's 3 pi over 4. Okay, so that location right there is 3 pi over 4. Okay, so also down here, minus 1 over root 2. Okay, so what are these x values? Well, that width and this width is the same. So this width is pi over 4. So that location right there will be pi plus pi over 4, which is 5 pi over 4. And this location here will be, this is 2 pi. Again, this is the same width as this. We gotta go left from 2 pi. So this is gonna be 2 pi minus pi over 4, which is 7 pi over 4. Wow, okay, so surprising, right? From this simple equation, we get 4 answers. And that's because we restricted from 0 to 2 pi. If the restriction was larger, domain, then we'll get way more answers. Okay, we could get way more answers, or even infinite answers if there was no restriction like that, okay? All right, so that's the first example of a quadratic trig equation. That's it for this one. I'll see you in the next.